dear students, welcome to the first class of PU2 Brahmastra series. Okay, so as you all know, we have started this very important series to cover your whole PU2 syllabus in the form of questions. So today I am your chemistry faculty here to discuss the chapter Haloalkanes and Haloarenes. Okay, so the objective of starting organic chemistry first is that so that you can complete it well in advance and you can do multiple revisions of organic chemistry, right? So and that is why I have started it first, and you will get enough time to revise the reactions, to write it again, practice it again, memorize it again and again. Okay, so my dear students, in this class we will be covering MCQ questions, we'll be covering short answer questions, 2 markers and even long answer questions. Okay, and one more very important thing, that if you want this notes, okay, I'll be giving you, but for that you need to join the WhatsApp channel. Okay, so the form and the link will be there in the description section, so please go there, join the WhatsApp channel, then everything will be shared with you. Okay, so now students, let's get started here. So if you see the blueprint of the blueprint that is released by the PU board, so haloalkanes and haloarenes carry 9 marks. Okay, and how is this 9 marks distributed? There will be there will be 2 short answer questions, there will be 1 2 marker question, and there will be 1 5 marker question. Okay, 1 5 mark, so and 1 2 mark, so 5 plus 2 7, and there will be 2 VSA question 8 and 9. Now this portion, right, so this portion is like what type of questions will be asked. It is like remembering and HOTS, understanding, remembering. Okay, but this division is different in different blueprint papers, so I have considered the first one, but we will not be worried about that. We'll be preparing all types of questions, so from wherever it comes, we can easily tackle it. Okay, so now students, in this video particularly, what all things are we going to discuss? So we are going to discuss VSA, that is 1 marker question, 10 questions will be solving. Okay, next 2 markers will be doing 25 questions, and long answer questions, which is very repeated, and predictive questions will be doing 5 important questions. Okay, now see here, I have made a series. After this whole PU things are over, we will start a dedicated MCQ series. Okay, in that particular series, from every chemistry chapter you will be getting at least 80 plus questions. Okay, I can guarantee you that. So in this video I have not included more MCQ questions, because it will get like the whole MCQ it will take more time. So what we'll do is, we will do another dedicated session on MCQs after the whole syllabus is over. After by January 15, as we promised you, we'll be completing all the chapters by Jan 15. After Jan 15 you will have revision time. At that time we will be launching only MCQ series of all the chapters. Okay, so that will be really beneficial. It will be near the exam, so you can remember all the MCQs as well. Okay, so that is why in this question we have just taken 10 MCQs. Okay, fine. So, and one very important thing you will get, most important topics in the last slide I have mentioned, what all things you should revise, what all things you should do, that all things I have explained here. Okay, so now let us go to the first question. Statement: enantiomers are non-superimposable mirror images on each other, right? So we know the concept of enantiomers in SN1 and SN2 reaction, right? That topic. Now a racemic mixture shows 0 optical rotation. Now a racemic mixture is what is a racemic mixture? It is a equimolar mixture okay, of both, suppose R and S configuration. Okay, or you can say dextro-rotatory and levo-rotatory. Okay, R and S equal composition will be there. So suppose if one component is moving it towards the right, other component will move towards the left, right? So that is why the net rotation is 0, and that is why racemic mixtures are optically inactive. So both the statements are correct, but we cannot say that this is the reason. There is no relation between statement 1 and statement 2. Okay, so the options are also like this. So both statement 1 and 2 are correct. Yes, option number A is the correct answer here. Now what you have to do exactly in this series, you need to see the question, write your answer, and then see the solution. Okay, in this way you can know like which questions you can able to solve, which questions you are unable to solve. Next, let us go to question number 2. 1,2-dichloroethane is an example of. So if you see, we have 1,2-dichloroethane, right? So if you see this one, In this, what is happening? 2 chlorines are present on the adjacent carbon, and that is your vicinal dihalides. Okay. Now, what is geminal dihalides? Geminal dihalides are 2 chlorines attached on the same carbon. Okay. Now, let us go to the next question. Here we have 4 haloalkane compounds represented by letters M, N, O and P having boiling point are this given. Okay. Let us note down M, N, O and P. So, M is how much? 24.2, N is 38, okay, O is 3.56 and P is 101.6. Okay. So, question is like this: among 4, the compounds N most probably is likely to be. We need to find the N value. Okay. So, now if you see these compounds that is given, okay, compounds boiling point depends on what? Okay, so boiling point depends on mass. Okay, more is the mass, more will be the boiling point, right? Here if you see there is 1 carbon, 2 carbon and 3 carbon here, right? So definitely its mass is more. Even the chlorine is like the halogen present is also iodine, that means this mass is more. If this is having highest mass, then its boiling point will be maximum. So out of these, if you see this P is having highest boiling point, so I can write C3H7I here. Okay. Next we can find out the lowest one, that is 3.56, right? So 3.56, if I see that has to be the lowest one. So here's 1 carbon, here also 1 carbon, here chlorine, here bromine, right? So chlorine is having lesser mass than bromine. So this compound A will have the least boiling point. So that will be your CH3Cl. Okay. Next, if I see the next 2, right? This is having C2H5Br. And so this boiling point is more, so that means this should be C2H5Br, okay, and this one should be CH3Br, right? So which is your N? Most probably N has to be option number C here. Okay, I hope you are able to get it. Okay. Next, the homologous series of alkyl halides are represented by the general formula. Okay, this is very simple question. You know, haloalkanes are, or any alkanes are represented by this formula. Now what happens? Any 2n plus 1, right? Now what happens? There is only 1 hydrogen is replaced with X group, right? So what happens? We get 2n plus 2. Okay, now there is 1 hydrogen is replaced, so it will become 2n plus 1. Okay, 1 hydrogen is taken out, so minus 1, and that hydrogen is replaced with X. So option number A is the correct answer. Okay. Next question: toluene reacts with a halogen in the presence of iron chloride, giving ortho and para halo compounds. The reaction is, so if you know that haloarenes give you, so remember haloalkanes. Okay, haloalkanes give nucleophilic substitution reaction. Okay, but haloarenes will give you, haloarenes or benzenes will give you electrophilic substitution reaction. Okay, so that's why I can make that, because it is toluene, right? So we have toluene is a aromatic compound, right? So it will give you electrophilic substitution reaction, that is option number B here. Okay. Next, which reagent will you use for the following reaction? So here you can see halogenation is taking place, chlorine and chlorine, but chlorine is sometimes added here, sometimes added here, right? And that chlorination, when this type of products are formed, it is due to free radical mechanism. Okay. Now if free radical mechanism is there, then what will be the reagent for that? Chlorine and UV light follows free radical mechanism. So option number A. Okay. Next, question number 7, arrange the following compounds in increasing order of their boiling point. Okay, so just now we discussed, so boiling point depends on what? Mass, and is inversely proportional to branching. Okay, if more branching, boiling point is less, if less branching, boiling point is more. Okay, now if you see here that we have this compound, if you see B1, okay, just a minute, yeah, see this B compound, okay. Now this is having a straight chain, right? If it is a straight chain, its boiling point will be maximum. So B will be maximum, and I can see that there is only one option with B maximum. So definitely this one will be there. Now here you see there is more branching, so this one will have least boiling point. So C should be least and then A. Option number C is the correct answer here, okay. Next, the position of Br in the compound can be classified as, okay. So here we need to discuss certain things. So suppose if you have like this, okay, this is called as vinyl, okay, when the halogen is attached to an sp2 carbon directly. Next, what is allylic? If you have bromine here, means carbon containing bromine is attached to an sp2 carbon, okay. Here bromine is directly attached to sp2 carbon, here bromine is attached to one carbon, and that carbon is attached to an sp2 carbon, right. In that case, we call this one as a allylic carbon, okay, or allylic halide. Now here if you see, the condition is like this: CH, then I have CH, then we have C, then we have Br, here we have CH3 and CH3, right. So now what I can say, this carbon which contains the bromine group is present next to the sp2 hybridized carbon, right. So that means it is an allylic carbon, option number A here. Okay, next, chlorobenzene is formed by the reaction of chlorine with benzene in the presence of AlCl3. Which of the following species attacks the benzene ring in this reaction? Okay, so students, first of all, here you should know, as we just discussed, that haloarenes, okay, haloarenes will show what type of reaction? Electrophilic substitution reaction, right. Now in this electrophilic substitution reaction, always this one should be something positively charged. The attacking ion should be positively charged, right, because it is an electrophile. Seeing that, we can eliminate these all options and the correct answer will be option number B, okay. But I'll tell you the exact mechanism. What happens, we take chlorine, okay, when reaction in the presence Cl2 in presence of AlCl3, okay. Now what is formed here? We get Cl plus and AlCl4 minus is formed. Now if you have a benzene ring, what happens? This electron density of benzene attacks on this chlorine, okay. That is how the reaction takes place. Okay, next, what is A in the following reaction? Okay, so this is your addition of HCl to the double bond. So if you see here, what happens, we have CH2 CH double bond CH2, okay. Now when you add HCl, okay, addition of HX follows Markovnikov's rule, okay. Now what does this Markovnikov's rule say? I hope all of you would be knowing this, that the negative part will attach to the carbon having less hydrogen, right. Now if you see, you have to compare only the carbons in the double bond. Now if you see these two carbons, right, this carbon is having one hydrogen, this carbon is having two hydrogen. According to Markovnikov rule, the negative part, this is H plus, this is Cl minus, right. So the negative part will go to the carbon having less number of hydrogen, right. So that means this chlorine will attach here and H will attach here, and the product formed here will be CH2 CH Cl and CH3, right. H got attached here, so it became CH3, chlorine got attached here, so it became CHCl, okay. So now if you see, the answer has to be option number C here, okay. Fine. Next, if we see here, okay, so students, one second, this question I'll discuss this question once again, okay. The question was like this: you have CH2 C double bond CH and CH2, okay. So I did a mistake here. Please see this question, mark it important. Okay. Now what happens according to Markovnikov's rule? If you see what will happen, we will get a positive charge here. Okay, once this bond breaks. Okay, so we get a positive charge here and we get a negative charge here, right? This negative charge, and we are attacking HCl, right? H plus and Cl minus. So what will happen? Negative part will go here, plus will come here. But there is something that we missed here. So that is what first I'll tell you. First, this H plus is attacking here, so it gets CH. Okay. Now here you see there can be, if we get a positive charge on this carbon, right, then what will happen? That will be a benzyl carbocation, right? Carbocation next to the carbon, next to the benzene ring. Benzyl carbocations are very, very stable. So that is why what happens here, there is a rearrangement taking place. Okay. Now due to this rearrangement, what happens? One hydrogen shifts here. Okay. So I can say H minus or hydride shift. So in this hydride shift, what will happen? We will get CH to CH3. Okay, this one goes here, and now we get a positive charge here, right? And this positive charge is very stable due to resonance. Now what happens? The negative chlorine will attack on this one. Okay, not here. If you just simply follow Markovnikov's rule, then we can mark this one as the correct answer. But we need to think that this carbocation is a secondary carbocation, but this carbocation is a benzyl carbocation, right? Very stable. That is why here a rearrangement is taking place. Okay, rearrangement is taking place. The hydrogen shifts here, we get a positive charge here, and then the chlorine attacks here, right? So the correct answer here will be option number D. Okay, so please change this. Okay, so fine. Now we will go to the next question, that is next part, that is 2 marker question. So students, as I told you, I'll be making a dedicated video of 100 MCQs per chapter of organic chemistry, definitely. So that is why here I have taken 10 important questions. In the next, if you on the upcoming, you please follow this series. In the upcoming, you will be getting the like all MCQs at one place. Okay, so that is why I don't want to make this video more lengthy. We'll go to the 2 marker questions now. Okay, so if you see, we have, what are the topics? I just want to discuss in brief what are the topics in this chapter. Okay, the first topic is your methods of preparation of haloalkanes. Why I am discussing this? So that you can know where are the questions can be asked. Second is methods of preparation of haloarenes. Okay, next we have physical properties. Okay, next we have chemical reactions of haloalkanes. Okay, and similarly fifth one is chemical reactions of haloarenes. Okay, and the sixth one is polyhalogen compound. Okay, now these are the most important topics present in this particular chapter. Okay, from where you can expect the 2 marker questions. The first thing is, I can say all these important things are there from where you can expect, but definitely in physical properties you can expect boiling point order can be asked. Okay, then I'll be telling you topic wise where you can expect the questions. Okay, and in this chemical reactions SN1, SN2 definitely you will get. So these 2 things are very, very important. Please focus more examples of SN1 and SN2. Okay, so now we will see the first question. Explain Swartz reaction with an example. Whenever such question comes, it is a 2 marker question. First statement you need to write, then you need to write the example. Whether it is asked to write an example or not, do not worry, but whenever any reaction is asked, make sure to write the statement and then the example. Okay, so now if I tell you, okay, so Swartz reaction, how you can write down? So I'll tell you the easy way. Okay, so I'll erase everything. Okay, one second. Yeah, so if you know Swartz reaction, how do we think? Just remember the reaction. You take Rx, okay, you treat with AgF to get Rf, right? This is the reaction. We get this one and we get plus Agx. right? So now you do not have to frame this much big answer, okay? You can write in very simple words. I'll write and show you. You can write down alkyl fluorides, okay? So I'll just write down here. In my statement, if I am a student, how will I write? So I'll write, I know the reaction, right? Just I need to write the statements. So alkyne fluorides can be prepared by the reaction of, okay? Here we know what? Chloroalkanes or bromoalkanes, by the reactions of chloro or bromoalkanes, okay, in presence of, what is the reagent required here? In presence of metallic fluorides, like AgF. If you remember anything else, you can write down, or you can just write down AgF, right? This is what I am going to write in the exam. Alkyl halides, I know the reaction that chloroalkanes or bromoalkanes will react with silver fluoride to give you fluoroalkanes, right? So I can write down alkyl fluorides or fluoroalkanes reacts in the presence of metallic fluorides to give alkyl fluorides can be produced by reacting chloroalkanes or bromoalkanes in the presence of metallic fluorides, right? So that is the reaction. This is the book's definition I have taken, but you can write exactly how I have written. This is very, very simple, okay? So next, this is the first thing. Next, when you are writing the example, do not take like this X and all, do not take a particular direct example you take. So I have taken CH3Br plus AgF, right? Then what will happen? Here there will be an exchange. This Ag will take Br and CH3 will take F. We will get CH3F plus AgBr, okay? Fine. Next, we'll go to the second question, that is Finkelstein reaction. Okay, so these are from the methods, you know, halogen exchange method. From that the questions have been taken. So explain Finkelstein reaction with example. Okay, so again Finkelstein reaction is for the preparation of iodoalkanes, right? So similarly, the basic definition you can write down: iodoalkanes can be prepared by reacting chlorohaloalkanes or bromoalkanes in presence of NaI dry acetone. Okay, so that is what you can write. Alkyl ionides can be prepared by the reaction of alkyl chlorides or bromides with NaI dry acetone. Okay, so example you can write down here. One second. So I can just write one example and show you. So I'll write CH3Cl, okay, in presence of NaI and dry acetone. Okay, so this one will give me CH3I, okay, plus NaCl. Okay, so students, now just tell me how many, if you are attending the class, please put an attendance here that you are present, and tell me if you are getting everything or not, if you are understanding how to present the answer. Okay, that is very, very important. Any doubt, students, please comment down. I will definitely address it. We are going to complete the all important questions. Apart from this, you do not have to study any other question. I can guarantee you that. Okay, whatever questions I am discussing here, you just need to do those questions. Okay, apart MCQ, you don't for 2 marker and 5 marker. This is your preparation thing. You can study these questions, that will help you. Okay, fine. Next, how do we prepare alkyl halides from alcohol? So you can see these questions have been asked in 2014, 16 and 15. Okay, repeated question. So there are different methods. Okay, from there are almost 4 to 5 methods from which by using alcohols you can prepare alkyl halides, right? Some of which I can remember now is like if you have ROH, okay, and if you treat it with HCl and anhydrous ZnCl2, okay, you can treat it with then you can treat it with PBr3, right? You can treat it with PCl3, then you can treat it with PCl5, right? Then you can treat it with SOCl2, right? So these all will give you haloalkanes. This one will give you RCl, this one will give you RBr, this one will also give you RCl, this one will give you RCl, this one will give you RCl. right? So we have so many methods, you can take any one of them, but as we know that the most preferred method is this one, right? Why? Because gaseous byproducts are produced, right? So you can better write the last reaction. Okay, so you can see here alkyl halides can be prepared from alcohols by treating with SOCl2, that is thionyl chloride. This is a preferable method as the byproducts produced are gases. Okay, so this one will give you 1 mark. Okay. Now after that you need to write the reaction. So do not write any R or X, use the complete, write an exact reaction. So I am writing like this: CH3OH plus SOCl2, okay, will give me CH3Cl plus SO2, okay, plus water. Byproduct you can write down. Okay, so that will be so that will be your byproduct, and all the byproducts produced here are gases, so it can be easily preferred method. Okay, fine. Next we have, how do you prepare alkyl halides from alkenes by adding hydrogen halides and halogen? Okay, give examples. So this question was asked in March 2015. This you just need to write the reactions, okay, nothing else. So first one, the reaction you need to write here, you need to take any alkene. So I am taking, like for example, CH2 double bond CH3. I have taken propene and hydrogen halides, right? So I will add HX, okay, and then I will write the product here, CH2 CHX, and here H, and here CH3. Here you can write down a statement: addition of HX follows Markovnikov's rule. Okay, that's done. Next, the second one, if I want to write CH2 double bond CH3, and this one you can take like addition of halogens, right? So if you just take bromine, so what will happen? 2 bromines will, the double bond will break and 2 bromines will be added. Okay, not CH2, it is CH. Clear? So that is the answer for this question. You just need to write the reaction. Okay, next question number 5 is an important in-text question of NCERT. Okay, a hydrocarbon C5H10 do not react with chlorine in dark but react with sunlight to give you monochloro compound, that is C5H9Cl. Identify the hydrocarbon. Okay, now if you see that the formula here is C5H10, right? This is of what formula? If you see CnH2n. If CnH2n is there, then either it can be an alkene, okay, or it can be a cyclic compound. That is the first thing we got. Now the second clue here is telling that it does not react with Cl2 in dark. Okay, so does not react with chlorine in dark. So if you remember, alkenes can react here, this reaction that we wrote, right? This reaction can take place even in dark. So if it is not reacting with chlorine in dark, that implies what? It is not an alkene. It is not an alkene, because if it would have been an alkene, it will definitely react with chlorine. Okay. Next, so we can say that what is the possibility? That this must be a cyclic compound, must be cyclic. Okay, now this is the first thing we got. Now next thing is what? It gives you a monochloro compound. Monochloro compound. Now if it is giving you a monochloro compound, what does it imply? It implies that all the hydrogens are equivalent. Okay, all the hydrogens are equivalent. So now if you see, we have 5 carbon and we need to do a cyclic structure, and all the hydrogens should be equivalent, then we will get this structure, that is cyclopentane. This is cyclopentane. Okay, cyclopentane group. Okay, so the answer for this question will be cyclopentane. But you need to write these statements and then so the final answer is cyclopentane. Okay, that is the same thing I have explained here. Okay, let's move to the next question. Give the preparation of aryl halides by Sandmeyer reaction. Okay, so we are still in the preparation now. One second. Okay, so we have done the preparation of haloalkanes, some questions. Now we are doing the preparation of haloarenes. Okay, Sandmeyer reaction. So if you remember, first this is just Sandmeyer reaction. I'll write the reaction, then always try to know the definition. So you have here aniline, okay, and when you react it with nitrous acid, we get benzene disonium chloride. Okay, and next if you react this one with CuCl HCl, or you react it with CuBr HBr. Okay, so CuCl HCl will give you chlorobenzene and CuBr HBr will give you bromobenzene. Done? So how will you write the statement? Just think about this and then write the statement. No need to remember the bookish statements at all. Okay, so how can you write down? You can write down when aniline, okay, this is aniline, when aniline reacts with nitrous acid to form benzene disonium chloride. Benzene disonium chloride in presence of CuCl HCl or CuBr HBr gives chlorobenzene or bromobenzene respectively. This is called as Sandmeyer reaction. Okay, so I have written this the same thing. Aniline reacts with dilute nitrous acid to form benzene disonium chloride, which reacts with CuCl or HCl to give aryl chloride or aryl bromide. This is Sandmeyer reaction. Okay, the statement should be in your own words. From the reaction you can easily derive it. Okay, next question number 7. In haloarenes, para isomers have higher melting point as compared to their ortho and meta isomers. Why? Okay, so this is also from the question is from physical properties. So they see we are going step by step. Okay, haloalkanes, whatever are the methods of preparation of haloalkanes, what all are the possible questions I gave you. Next, preparation of haloarenes, the possible questions we have discussed. Okay, next we are going to the physical properties. Okay, so in physical properties, if you see, para isomers have higher melting point as compared to their ortho and meta isomers. So the reason here you can write down that para isomers, first point, para isomers are, so whenever you write a 2-mark question, try to write it in the form of points. Okay, para isomer are symmetric in nature. Okay, so you can just draw like this one para isomer. Okay, para isomers are symmetric in nature. Now due to their symmetry, what happens if they are symmetric? Due to their symmetry, they fit well. So single T, okay, they fit well. They fit well in the lattice. Okay, due to this symmetry, they fit well in the lattice and have high boiling point or melting point, whatever is asked, higher melting point, sorry, and have high melting point. So if you write this first point, this is second point, you will get 2 marks easily. Okay. Now let us see the next question. So again in the physical properties, arrange in the increasing order of boiling point. So you know boiling point depends on 2 things, mass and branching. More mass, more boiling point, more branching, less boiling point. I hope this is clear to all. So now if you see bromomethane, bromoform, chloromethane, dibromomethane. So first let us draw the structures of all. Okay. So if you have first here bromomethane, CH3Br. Next we have bromoform, CHBr3. Chloromethane, CH3Cl. Next you have dibromomethane, dibromomethane. methane. Okay, so definitely you can very easily, you see there are 3 bromines, so mass will be here maximum. You need to arrange in the increasing order, means the least one will come first and then the highest one will come at the last. So if you see here, all are having 1 carbon, here there is 1 chlorine and here there is 1 bromine. Chlorine mass is least, so chlorine will come at the least, so we will have CH3Cl, then CH3Br, then CH2Br2 and then finally CHBr3. Clear? I hope all of you are getting this. Okay, now if you do the second point, 1 chloropropane, isopropyl chloride and 1 chlorobutane. Okay, so I will write this one here, we need to draw the structures. Okay, so let me do the second question here. First one is 1 chloropropane. So we have CH3, CH2, CH2Cl. Next, isopropyl chloride, CH3, CH, CH3Cl. Next, chlorobutane, right? 1 chloropropane, isopropyl chloride, 1 chlorobutane, CH3, CH2, CH2, CH2Cl. Okay, so now you see the first 2 compounds are having only 3 carbons, right? The last compound is having 4 carbons, so definitely mass here will be maximum, so this one will be highest, but we need to write in the increasing order. So out of this, which one will be least? Here also you see 3 carbon 1 chlorine, here also 3 carbon 1 chlorine, but here what we have? Here we have branching, and due to the branching the boiling point will decrease, right? Here you see this is a straight chain, this is a branch chain, right? So that is why the boiling point of this one is less and the order will be CH3, CH, CH3 and Cl. Okay, and then we will get CH3, CH2, CH2, Cl, and then we will get the butane one, that is this one. Okay, I hope the answer is clear, students. If you are able to answer, if you are liking the session, please like the video and share it with your friends so that all of us can study together. Okay, if you have any doubt in any concept, that also you can comment down, and do not forget to join the WhatsApp channel. All these questions will be provided to you. Okay, fine. Next is question number 9 here. Write the steps involved in SN1 mechanism for the conversion of tert butyl chloride to tert butyl alcohol. This is the most important question of this chapter. Every year you can expect SN1 and SN2 mechanism questions. Okay, so first of all it is asking steps involved. You just need to write the steps involved here. So the step number 1, okay, step 1 is what? Formation of carbocation. Okay, so we will write, I hope all of you remember, all of you know about this, I'll be telling you the answer. We need tert butyl chloride, right? So we can write like this: C, CH3, Cl, CH3 and CH3, right? Tert butyl chloride, what happens here? There is first position, there is the formation of carbocation, right? So this chlorine moves out, so that will give you what? A formation of carbocation. So we will get a carbocation here, okay, and a Cl minus will form. Next, step 2 is what? Oh, sorry, yeah, step 2 is what? Step 2 is, I'll change the ink here, attack of nucleophile. Okay, so when you are writing like this, right, underline this what? That is the step number 1. Underline this thing. Here you see we need to give a equilibrium symbol. Okay, next thing we can do attack of nucleophile. So here you can write down that we have this one CH3 whole 3 C plus. Okay, then you can show OH minus, attacks this one, and we get CH3 whole 3 C and OH. Okay, now because this is not a I can say not a, what I'll say, not a optically active compound. Why is it not optically active? For optically active we need all the 4 groups different. Here all the 3 groups are different, same, so that is why it doesn't matter whether you attack from here or from the back side. Okay, you can just write down this mechanism. Fine, let us 2 marks, 2 steps, 2 questions. Sorry. Next, question number 10, write the steps involved in SN2 mechanism for the conversion of chloromethane to methanol. Okay, so you need to write here, just you needed to write the steps. So chloromethane, right? So you can write like this, we have chloromethane, okay, in presence of methanol, so OH minus. What happens here? Here the attacks takes place from the back side, right? You have to show the backside attack. What we get here, OH bond is formed and we have CH, HH and we have chlorine. Now this is called a transition state, and then what we get here is CH3, one second, okay, so here we will get CH3 Cl. Okay, so sorry, OH is attacking, right? CH3 OH. So you can show OH on this side, but that doesn't make any sense here because it is optically inactive, right? So H here and OH on this side. Clear? So these 2 steps if you write, you will get 2 marks in this question. Okay. Next, question number 11. So we'll go to the stereochemical aspects of nucleophilic substitution reaction, especially of SN1. What is chirality? What is the condition of chirality? Okay. So first of all, what is chirality? That you need to explain. So here is the answer. See, the objects which are non-superimposable on their mirror images are called chiral molecules, and this property is called as chirality. Okay. So I can say that the definition of chiral molecules, okay, chiral molecules definition is equal to the definition of enantiomers. Okay. Okay, chiral molecules you can write down are those chiral, the objects which are non-superimposable images of their which are non-superimposable on their mirror images are called as chiral molecules, and this property is called as chirality. Similarly, definition of enantiomers are those isomers which are non-superimposable mirror images of each other, right? So these 2 things you can relate and remember. And what is the condition for chirality? The condition for chirality is it should have an asymmetric carbon. Now what is this asymmetric carbon? This can also be called as chiral carbon, or this is also called as stereocenter. Okay, asymmetric carbon is equal to chiral carbon is equal to stereocenter. Now what is the definition of this one? The definition here is that the groups attached to all the 4 groups, so I can write it like this. What is chiral carbon or asymmetric carbon or stereocenter? All the 4 groups, okay, attached to carbon should be different. Getting? All are getting this one? Okay. This is a definite question, most of the time either stereocenter, chiral carbon, asymmetric carbon, chirality, enantiomer are asked again and again. Okay, so please remember these definitions properly. Next, we have a question here, butane 2-OL is a chiral molecule and optically active, explain. Okay, so here is a very important thing you need to think. You need to explain why it is chiral molecule, and then you need to explain why it is optically active. Okay. Now what is optical activity? So whenever a molecule is able to rotate the plane polarized light, it is called as optically active. Okay. Now what is the condition for optically active? That it should be chiral molecule, right? So just understand this here. Now let us see the next question here. Butane 2-OL is a chiral molecule and optically active, explain. Okay, this is a very important question because you need to know how to write this answer. Okay, now here you need to explain why it is a chiral molecule, and you also need to explain why it is optically active. Okay, now let us understand what is the meaning of optically active. Optically active. Okay, optically active means should be able to rotate plane polarized light. Okay, so any molecule which is able to rotate the plane polarized light is called as optically active. Okay, and for optical activity, what should be the condition? It should be chiral. Okay, if a molecule is chiral, it is optically active, and if it is optically active, it can be said that it can rotate the plane polarized light. Understand? So now the question is, butane 2L is chiral molecule. And just now we discussed what is chiral molecule. A chiral molecule is something which should have an asymmetric carbon, right? So first thing we can draw is the structure of butane. So butane 2OL, right? We have butane 2OL. Okay, one second. Yeah. Okay. So now if you see this carbon has 4 different groups attached. This side methyl, ethyl, OH and H. Because 4 different groups are attached, what I can say that it is a chiral molecule, right? So I can explain like this, that butane 2OL is a chiral molecule, because it has 4 different groups attached. Okay. Now, why is it optically active? So you can write down here, it is optically active. It is optically active because it can rotate plane polarized light. Okay, I have written PPL. So if you explain this one, this carries 1 mark here, and if you explain this one, this carries 1 mark. Got it? So 2 marks is awarded here. Next question. Okay, so next question is define retention. Give a chemical reaction that precedes with retention of configuration. Okay, so if you remember what is retention, SN1 and SN2, in SN2 reaction mechanisms there is retention, right? So you can write down what is retention. Retention is the what I can say, when a reaction happens and the configuration remains same, then we call it as a retention. Okay, explain definition I'll show you. Retention is the preservation of the spatial arrangements of bond at asymmetric carbon. Okay, or you can just write down retention is that when the configuration of the reactant and products remains same. Okay, it does not contain asymmetric carbon. Okay, so now if you see here, okay, now we can write given chemical reaction that proceeds with the retention of configuration. So for this one you need to write any SN2 mechanism. Okay, and if you remember we have SN2 mechanism, we can do any SN2 mechanism like this. Suppose I have chlorine, okay, and I have here this side CH3, okay, and I have 1, 2, and I have here H, and here I have suppose 1 more H. Okay, or we can make it CH3. Okay, so now if this reaction is happening like this, OH minus you are taking, okay, and this one is attacking from this side, and we get a transition state here. So I'll draw it like this. Okay, CH3, we have H, we have CH3, we have Cl. Okay, then if it reacts here, we will get OH on this side and CH3, CH and CH3, right? So here what happens? Okay, one second, sorry. The question here is 13 number, define retention. Okay, give a chemical reaction that proceeds with the retention of configuration. So if you remember that in case of SN1, okay, we have retention of configuration. Okay, like we get both retention and inverted product. In SN2 we get inverted product, right? So you can write down what is the meaning of retention. Now retention is when the configuration of the reactant and the products remain same. okay, or you can say the spatial arrangement of the reactant and the products are same. Okay, so let us see the definition here. Retention is the preservation of the spatial arrangements of bond at asymmetric carbon. Okay, so at the asymmetric carbon there is no change in the bond. So here you need to give an example. So here if you do any SN1 reaction, okay, so retention will be there. So let us try, suppose we are reacting butane to OL, right? So what will happen if I am reacting butane to OL? So I have OH and I have here CH2, CH3, and this side H is there, right? So in the first step what happens? So I'll butane chloride I'll react. Okay, so at the first step what will happen? Chlorine will come out. So we will get CCH3, CH2, CH3, CH2, CH3, and C and H. Okay, now this is plus charge. Okay, now this OH minus, can it attack from this side also, can attack from this side also, but if it attacks from this side, then what I'll get? C, CH3, OH, okay, and we have CH2, CH3, and then CH, right? So this is your retention of configuration. Okay, now next question you see, define inversion or give a chemical reaction that proceeds with inversion of configuration. Okay, or SN2 reactions of optically active halides are accompanied by inversion, explain with an example. So just same thing you can write down. So in inversion what will happen? The spatial arrangement of the reactants and the products changes, right? So that is the definition you can see. If the product of the reaction has opposite configuration to that of the reactant during reaction is called as inversion of configuration. Now how will you explain? Give a chemical reaction, so you can take any SN2 reactions. Okay, so for example if I have, right, suppose I am reacting CH3 and here this side it is suppose chlorine, this side it is H, and suppose here I this side I take any other group, let it be NH, or make it, let it be CH3. Okay, it should be optically active, right? One second, CH2, CH3. Okay, so now if you see, okay, same example I am taking, I will make a different example here. So now let us see this question. Define inversion, give a chemical reaction that proceeds inversion of configuration. Okay, so inversion we can find in SN2 reaction mechanism, right? So first you can explain inversion like this. If the product of the reactant has opposite configuration to that of the reactant, then during the reaction it is called as inversion. Now if you just want to write one example for inversion and explain it, so that is given in the question, so you can take like this, the same example we can take CH2, CH3 and OH, right? So and suppose here the reaction is taking place in terms of SN2 mechanism. So what will happen? OH minus will attack from the opposite side, right? And here we will get a transition state. So we will get OH, so this is H, right? One second, yeah. So we will get here OH, here CH3, okay, and this side it is Cl, and this side it is H, and this side it is CH2, CH3. Okay, now what happens here? This one will be dotted. Okay, clear? Now what happens after this? This bond will break and we will get CH3 this side, OH this side, and we have H this side, and CH2, CH3 on this side, right? So you can see chlorine was present on reactant in this side, but in product OH is formed on this side. So there is an inversion of configuration, that is why this is called as inversion. Okay. Next question number 15, how does alkyl halide reacts with alcoholic AgCN? So very easy question, just you have to write down what is happening here. So you can write down like, okay, I'll show you the answer here so that I can save some time. You can see here, alkyl halides react with AgCN to form isocyanides. Okay, that's all you need to write. Then give equation. So you can write down like for equation anything you can take like CH3Cl. So I'm just giving example, can be reacted in presence of AgCN to give CH3NC plus AgCl. Clear? That is the reaction. Now similar reactions, similar questions can be asked with these reagents as well. If it is reacting with KCN, so what will be the product? You will get cyanides here, right? The same definition you need to write, that alkyl halides react with KCN to form what? To form cyanides. And how will be the reaction? You can just write down. So suppose I am marking this as one A, B, C and D. Okay, let me see if I left any way. Okay, yeah, so I'll write the reactions here and definitions will same as it is. So for A it will be CH3Cl with KCN, you get CH3CN plus KCl. Okay, that is the A1. Now if with carboxylic acids, what will happen? With carboxylic acid it gives you esters. So you can write down alkane halides react with carboxylic acids to form esters. Okay, now how will be the reaction here? So I'll write that reaction. You have CH3Cl plus carboxylic acid, right? So I have CH3COOH. So here what will happen? HCl will form and we will get CH3OCOCH3. Right? So this one will give you what? This one will give you esters. Next, with AgNO2, you will get nitro compounds, and with KNO2, you will get nitroso compounds. Okay, so that are the things. The same thing, reaction based, you have to write the exact definition, everything will be same, only this part will change, right? Okay. Next, question number 16, haloalkanes react with KCN to form alkyl cyanides but with AgCN to form isocyanides. Explain. So this is again important question. So in KCN what happens? This is an ionic compound, right? C can also give you electron, N can also give you electrons, but CC bond is more stronger, so that is why C gives you electron and CC bond is formed and cyanides are formed. But in AgCN what? This is an covalent compound, right? So if covalent compound is there means, okay, this is a covalent bond, so this C has no electrons to donate, only nitrogen can donate, so that is why we get NC. So you can write down like this, KCN is ionic, both carbon and nitrogen can donate electrons, but carbon only donates because CC bond is more stable, okay, than CN bond. So here you can add one line, more stable than CN bond, okay. Next, AgCN is a covalent in nature and N is free to donate electron pair forming isocyanides. Okay, this is an important question. I hope the answer is clear here. Okay, next, out of CH2, okay, the two compounds are given, which is more active towards SN reaction 1 and Y. So first of all you need to write which is more active, okay, out of these two. So you can see here what will happen. If you see in SN1, what is the first step? Formation of carbocation, right? So if you see the first one, we have CH2, CH, CH2Cl, right? So Cl will go from here and carbocation will form here, right? So this is the carbocation for the first one. And if you see second one, we have CH3, CH2, CH2Cl, right? Again Cl will go from here and we'll get a positive charge here, right? So now out of these two, which carbocation is more stable? So if you see here, we have resonance, okay, we have resonance here. Due to resonance, this carbocation will be more stable, right? So that is why this one will react faster. So first you need to write which is more reactive. This is more reactive. If you write this much, you will get 1 mark. Now why? Because here you can write a stable carbocation is formed. Now you can also show the carbocation here, that is CH2CH, CH2 plus, then you can show the resonance here and we get here CH2 plus CH double bond CH2. Okay, so due to this resonance, what happens? This carbocation is more stable. Okay, fine. Next, explain Z. So we have come to now elimination reaction. Explain Z-safe rule with an example. Okay, so what is the explanation? According to Z-safe rule, during dehydrohalogenation, more substituted alkene is formed. Okay, so you can see this question has been asked repeatedly. So very important question. Explain with an example. So you can just take like any asymmetric alkene you need to take. Okay, so I'll say, suppose I will take 2-chlorobutane. Okay, okay, And for dehydrohalogenation, what is the reagent required? Alcoholic KOH. Okay, so now if you see, I can draw this one like this to explain you. Here I will take an H, here I will take one H, okay, and here I will take one H. 1 second, okay, right. Now if you see, in dehydrohalogenation what happens, either this HCl can be lost or this HCl can be lost. If this HCl is lost, we'll get an alkene here. If this HCl is lost, we'll get an alkene here. Now more substituted alkene is this one, right, because we have more number of carbons beside the double bond, so we can get two products. See, one product is like this, CH2, this is one product, and we will get another product like this, right. So now if you see, in this, in between the double bond there is more number of carbons, so this is more stable. So this example you can write down here, right. So I'll get CH2, CH double bond, CH, CH3. Okay, clear. Next, electrophilic substitution occurs slowly in haloarenes compared to benzene. Give reason. Okay, so in haloarenes what happens? So see, for electrophilic substitution, okay, if this is a benzene, for electrophilic substitution, this ring should behave what? It should be nucleophilic. Okay, but this X is what? It is an electron withdrawing group. It withdraws the electrons, makes the ring more electrophilic. So that is why the reaction with electrophile slows down. Okay, so due to the -I effect of halogen atom, haloarenes have some tendency to withdraw the electrons from the benzene ring. As a result, the ring gets deactivated as compared to benzene, and hence the electrophilic substitution reaction occurs slowly. Okay, due to the presence of halogen, that electron withdrawing nature, the ring becomes more electrophilic. So if it is electrophilic, it will not react easily with electrophile, and in comparison to that, if we have just a benzene ring and a electrophile, here there is no electron withdrawing group, so this will react fast, right. That is the concept here. Okay. Next, aryl halides are less reactive towards nucleophilic substitution reaction. Give reason. This is the very important question. Okay, okay, this question is very important. You can see how many times it is repeated. Okay, so here the answer is very simple. The first one is your resonance effect. Due to resonance, what happens? Partial double bond character is formed, so the X cannot go out easily. That is the first point. Then the sp2 hybridization of the carbon. Okay, the question is saying is this one. See, suppose you have any Rx and nucleophile comes, okay, then easily this reaction will take place. Okay, this is very easy. But same thing if it is an benzene ring and if a nucleophile comes and replacing this one, okay, this reaction does not take place. Okay, this reaction does not take place. What is the reason for that? So the first one is your resonance effect. Due to resonance, what happens? These electrons are in resonance and there is a partial double bond here. Due to this partial double bond, this bond cannot break easily. That is the first point. Next point is, if you see here, okay, this carbon, okay, this carbon is sp2 carbon, right? sp2 carbon in X, bond is very strong. If the bond is very strong, again it becomes very difficult to break it. Okay, that are the two reasons here. Okay, next question number 21. How will you convert chlorobenzene to phenol by Dow's process? So if you remember, 300 pressure and 3 Kelvin and 600 pressure something. So chlorobenzene on reaction with NaOH with 623 Kelvin and 300 atm pressure gives phenate ion, which on acidification gives phenol. So just simply you need to write the reaction here. So if you have chlorobenzene and you treat it with NaOH, one second, okay, one second, eraser, yeah. So now if you treat it with NaOH, okay, at what we need 623 Kelvin and 300 atm pressure and H plus and water, then you will get the phenol here. Okay, clear? Next question number 22. Explain Fittig reaction, Woods Fittig reaction and Fittig reaction. Okay. Sorry, this one will be Woods reaction. Okay, here also it is very simple. See, in Fittig reaction what happens? Two aromatic compound reacts, okay, to give you Okay, this is Wittig reaction. In second one, Woods-Wittig reaction. So before that, let us discuss Woods reaction. So in Woods reaction, what happens? 2 R group reacts to give you RR plus X2. Okay. Next, in Woods-Wittig reaction, what happens? 1 aromatic compound and 1 alkyl compound reacts to give you ARR. Okay, these are the 3 different types of reaction, very easily you can remember. So just you need to change the definitions. Aryl halides, when treated with sodium in dry ether, give compounds where 2 aryl groups are joined together. It is called Wittig reaction. Okay, example you can see like this. Okay, next, if you want to write Woods-Wittig reaction, you have to write when aryl halide and alkyl halide react with sodium in dry ether to give a compound where 1 alkyl and 1 aryl groups have joined together is called as Woods-Wittig reaction. And for Woods reaction, you can write down when alkyl halides react. The same thing you have to write for alkyl halides. Okay, so that is definition. So I can write it examples for Woods-Wittig. Okay, so Woods-Wittig reaction is like, Woods stands for, you can take any haloalkane. Okay, and Wittig reaction, you can take any aromatic, or I can say haloarenes. Okay, and this one is taking place in presence of sodium dry ether, right? So I can write 2Na and dry ether. So in this case, 2 chlorine will be lost and we get CH3 and benzene. Okay, that is done. Now second one is your Woods-Wittig. After that you have Woods reaction. Okay, now for Woods reaction, what happens? If you have CH3Cl plus ClCH3 in presence of 2Na and dry ether, okay, you will get this chlorine will be removed and you will get CH3CCH3. Okay, so this is your Woods reaction. Just I hope you can write down the statement, very easy, just you need to write the reactants and products. Okay, next, question number 23, explain the nitration of chlorobenzene. So here I will tell you how to write the answer and I will give you the similar questions. So you can write down when chlorobenzene reacts with concentrated HNO3 or concentrated nitric acid to form ortho and para nitro products. Okay, you do not have to write when, you can write down just like this. Okay, one second, can just write down chlorobenzene reacts with a concentrated HNO3 to form ortho and para nitro product. Okay, now this is called as nitration. Okay, this is nitration. This is called as nitration. Okay, that point you need to write and then you have to explain, that is reaction you need to write. So chlorobenzene with concentrated HNO3 will give you what? Ortho and nitro products, ortho and para. So we will have chloro group with nitro group plus we can have chloro group with nitro group, right? So that is the for nitration. The similar question can be asked for halogenation, sulfonation and Friedel-Crafts reaction. So for halogenation, what will be the reagent? Cl2 in presence of FeCl3 or Br2 in presence of FeBr3, right? I hope you can write down this one. Okay, so one second, I'll write in this slide. So for halogenation, okay, I hope statement will be what? Halogenation statement will be chlorobenzene reacts in presence of Cl2 or FeCl3 and or Br2 in presence of FeBr3 to give you ortho para substituted products. Okay, so here the reaction is like this. So if you have chlorobenzene, okay, and you treat it with Cl2 in presence of FeCl3 or Br2 in presence of FeBr3, we will get ortho and para substituted products, right? We'll get this one and this one, okay? Or you can get, if you have taken bromine, then you will get Cl and Br plus you will get Cl and Br, right? Clear? That is there. Now if you react the next part, that is one second, okay. Now if you react this part, that is sulfonation. For sulfonation, what you need to do? You just need to take chlorobenzene, treat it with concentrated H2SO4 to get sulfonic acid. Again the same ortho product and the para product, okay. Now similarly you can take, for Friedel-Crafts acylation, you can take CH3Cl in presence of AlCl3, and Friedel-Crafts acylation you can take CH3COCl plus AlCl3. So here what you will be getting the products, same ortho and para product. So chlorine with CH3 plus here we will get chlorine with CH3, right? This is alkylation. For acylation, what you can do? You can do chlorine with COCH3 plus you can have chlorine with COCH3. Clear? That is all reactions that have been, one single question, similar questions can be asked here, okay. Next 24, what are Grignard reagents? Write its general formula. So organomagnesium halides are called as Grignard reagent, and what is its formula? Formula is RMgX, okay, and you can write down example like CH3MgCl, okay. Next question number 25, water freons, name the poisonous gas evolved when Cl2 is oxidized by air. So chlorofluorocarbon compounds of methane and ethane, okay, are called as freons. Chlorofluorocarbons of methane and ethane are called as freons, and when one second, name the poisonous gas evolved when chlorine is oxidized by air, and that is your phosgene, okay. So this is not chlorine, this is chloroform, okay, yeah. So that is phosgene COCl2, okay. Next, chloroform is stored in closed dark colored bottles. Why? So that is the here. Chloroform is slowly oxidized by air in the presence of light to a poisonous gas, that is COCl2, also known as phosgene. You can write down the reaction here. So that is why it is stored in closed or dark bottle, so that it doesn't react, okay. Clear? So yes, we are done with the 2 marker questions. Now we will go to 5 marker questions, okay. So what is the first thing? You need to write down the products here. First one. So first one, if you see, this is addition of HBr, it will follow Markovnikov's rule, right? So here there are, in this carbon 2 hydrogen, here 1 hydrogen, so negative part will go here. So I will get CH3C, here H, and here Br, and here CH3, okay. Next, if you see sodium diether, we have here how many carbons? 4 carbon. This is Wood's reaction, and in Wood's reaction the product is always the double of the reactant. So you can take it like CH3Cl. Na diether, you will get this one. Next, chlorine NaOH 623 is 300 atm. So we have just discussed this one. This will give you phenol here, right? Which process is this one? This is Dow's process, okay. Next, explain Sedzeff rule with an example. We have just discussed the question, whole question. The when alkyl halides undergo dehydrohallucination, the more stable alkene is formed. Then you need to write one example for this one, okay. Next, write any 3 differences between SN1 and SN2. Identify A and B in the given reaction, okay. So let us do this question. So you just need to write SN1 and SN2, any 3 differences, okay. SN1 and SN2. So the first difference here you can write down, it is a 2-step reaction, right, and it is a 1-step reaction. Second point you can write down, here intermediate or carbocation intermediate is formed. You can write down here, yeah, here you can write down carbocation intermediate is formed, okay, and here you can write down transition state is formed, okay. There is no intermediate in the SN2 mechanism, so transition state is formed. Okay, next you can write down this is first order reaction and this is second order reaction. Okay, there are many differences, you can write further points as well. Okay, next identify A and B in the following reaction. So this is what, NaNO2 HCl. So this one will give you what, N2 plus and Cl minus, benzene diazonium chloride. Now this one is your Sandmeyer reaction. For this one you need that is CuBr in presence of HBr. Okay, so that will ease your Sandmeyer reaction. Next, write the mechanism involved in the conversion of 2-bromo-2-methyl-propane to 2-methyl-propane-2-OL. Okay, so if you see 2-bromo-2-methyl-propane, so I have 2-bromo-2-methyl-propane to 2-methyl-propane-2-OL. 2-methyl-propane-2-OL. So if you see, this is which reaction? This is tertiary one, so it is your SN1 mechanism, right? So you need to write the SN1 mechanism that we have already discussed, right? So in which question, if I tell you which question we have discussed, so that you can check it very easily. One second, we have discussed in just a minute. We have discussed where, yes, we have discussed in question number 9. Okay, so you can see question number 9 here. So that will be that answer for that particular question. So I will refer this one. So you can refer for this one. The first one, A, refer to question number 9 of SA, 2 marks. Okay. Next, what are enantiomers? Name one physical properties which differ in enantiomers. Okay, so here you can write down the answers. What is enantiomers? Enantiomers, okay, are isomers which are non-superimposable mirror images of each other. Okay, now the question is name one physical properties which differ in enantiomers. So generally enantiomers have all the similar physical properties, okay, but there is one property which is different, that is rotation of plane polarized light. Okay, so one enantiomer will rotate it clockwise, another will rotate it in anti-clockwise direction. Okay, next question number 4, write the equation for the steps involved in SN1 mechanism. So again you can refer to question number 9 of SA2 markers. Okay, so next, name the product formed for the reaction of isopropyl iodide on alcoholic KOH. Okay, so B1 let us solve here. Okay, so if you have so this one will give you 2 markers. Okay, if you write the 2 steps properly, you will get 2 marks here. Next, you need to write for isopropyl iodide. So CH3, CH3, CH and I with alcoholic KOH. So what will this do? This will do dehydrohallucination, right? So there will be dehydrohallucination. Okay, now in dehydrohallucination what will happen? H and I will be removed and the product formed will be CH3, C double bond CH2. Okay, CH3, CH, CH double bond CH2. This is what? This is your isopropyl, when isopropyl iodide reacts with alcoholic KOH. Next, B2 will be what? What is the condition to be satisfied for a compound to be chiral? So we know all the 4 groups, just discussed this question already, all the 4 groups attached to the carbon should be different. Okay, Next, what is racemic mixture? So racemic mixture, the equimolar mixture of dextrorotatory and levorotatory isomers is called as racemic mixture, or else you can write down the equimolar mixture of enantiomers is called as racemic mixture. Okay, so I can tell you here that this term, okay, dextrorotatory and levorotatory isomers, instead of writing that, you can write down equimolar mixture of enantiomers. Okay, equimolar mixture of enantiomers is called a racemic mixture. Okay, another point, if you want, it has an optical activity or it is an optically inactive mixture. Okay, next question number 5 is again important here, that a primary alkyl halide C4H9Br. So we will do this step by step with the reading of question. We will be doing it. So there is an A, C4H9Br. Okay, primary alkyl halide C4H9Br. So this is must be primary as given in the question. Okay, reacts with alcoholic KOH to give you compound B. Alcoholic KOH to give compound B. Compound B treated with HBr to give you C. HBr to give you C. Okay, and C is an isomer of A. Okay, when A is reacted with sodium metal, it gives you D. Okay, when A is reacted with sodium ether, it gives you D, whose formula is C8H18. Okay, okay, which is different from the compound formed when N-butyl bromide is reacted with sodium. Okay, give the structural formula of A and write the equations for all the reactions. Okay, so now if you see, C4H9Br can have two isomers, right? This is one isomer possible. Another isomer possible is this one. Sorry, not this one because it is primary. One second, eraser. Yeah, so I can put Br here. Okay, so these are the two isomers possible. Apart from this, will not get anything. If you put this carbon, this is the same thing. Wherever you put, all the carbons are equivalent. So two isomers we have. Now the next point here is saying that this C18H18 is different from the compound formed when N-butyl bromide is reacted. So if N-butyl bromide is reacted, whatever compound we get, this is not that one. That means definitely your A should be this one, right? So I got A here. So A is CH3C, CH2Br, CH3, CH, right? So we have 3, 3, 6, 7, 8, 9, 1 bromine and 4 chlorine, 4 carbon, right? This is the A. Next, what is saying that if you treat it with alcoholic KOH, we will get B. So if I treat this one with alcoholic KOH, so what will happen? We will get a compound like this, CH3, C double bond, CH2, CH3. Okay. Now if you put HBr to this one, it will follow what? It will follow Markovnikov's rule. Br will be added here and I will get CH3, CH3. Let me draw it on the other side. One second. Okay, so if you treat here HBr, so what will I get? Here Br and here H will be added, right? So CH3, CH3, CH3 and CBr. Okay, so that will be the compound formed. So this is an isomer of A. Your A is this one. So definitely this is an isomer of A. So we have found out. Identify A. So this is first mark you will get where we have identified. This is A, right? And write all the equations for all the reactions. So this is my first reaction according to question. This is the first reaction. Okay. Next, compound B reacts with HBr. So this is the second reaction. Okay. When A is reacted with sodium metal. So we need to write this reaction. So I will write it here. So let me erase this part. Okay. So one second. Okay, so this is A we have got now. Okay, A reacts with alcoholic KOH to give you B. Okay, next B is a compound which reacts with HBr to give you C. Okay, next which is an isomer of A, so definitely these two are isomers. Next, when A is reacted with sodium metal, so we have this reaction, that is CH3 CHBr CH3 sorry, not CHBr, CH2Br, because it is a primary group, right? Okay, so yeah, so this side H and here it is CH2Br, plus the same compound can react again, CH3, CH, CH3 and CH2Br, right? In presence of sodium, what will happen? This XX will go and this two compound will react, so it will be like this. We will get, okay, CCC, then C, another C, and then this one. Okay, you will be getting this particular compound. Okay, this is your D. Okay, so that's all in this, students. So now I want to tell you some important topics once again. Please don't think that we haven't done the MCQs. MCQs, a special series I'll bring where I'll be discussing 100 questions from all the organic chapters, and in organic chapters physical chemistry definitely will have less because it is more about solving, but these two chapters I'll try to bring more than 80 plus questions. So please subscribe the channel, stay tuned. And now I want to tell you some important topics that you must do from this particular chapter. Okay, you cannot afford to leave it. So the first thing, definitions, you should remember these definitions. What is retention, what is inversion, one second, what is retention, what is inversion, what is stereocenter, and here I can add one more thing, that is chiral, asymmetric. Okay, so these all definitions are same. Then you can define racemic mixtures, enantiomers. Next, coming to name reactions, Schwartz reaction, Finkelstein reaction, Dow's process, Friedel-Crafts, Woods reaction, Fittig reaction, Woods-Fittig and Sandmeyer reaction. Next, coming to mechanisms, SN1 and SN2 mechanisms. Okay, so these are the important topics that you have to do. Clear, students? Okay, so students, we are done with this chapter, haloalkanes and haloarenes. You need to revise, practice these chapters, make a notebook where you are writing all these questions that I have given you. Okay, to get the PDF of this, you can join our WhatsApp channel, you can fill the form. WhatsApp channel will be joined and you can get the notes in your WhatsApp channel, in your WhatsApp directly. So please fill the form, and do not worry, students, all the chapters will be completed well in time. So please follow this Brahmastra series, and see you soon in the next class, that is on Thursday. Okay, so till then, prepare properly and all the very best. See you soon. Thank you. And if you like this video, do not forget to subscribe the channel. And if you have any doubts, do not forget to comment down. Okay, we will definitely address it.